Okay.
Well, thanks for coming over, Dr. Gordon. A great pleasure to spend some time with you. Mechanical engineering really is one of the next frontiers in both plant and animal sciences, in my opinion. We have a large center, the Center for Engineering Mechanobiology. This is one of the NSF's Science and Technology Centers that's really focused on bridging the disciplines of engineering and mechanics and mechanical engineering with the plant and animal sciences.
The evolution of microscopy stems from the past contributions of many whose vision and craftsmanship continue to reverberate as tools in projecting future scientific discoveries. For at least 35 centuries, desert sand was found to have special properties when heated with 2 parts alkali ashes from fern and beechwood. The resulting gas melt formation and clearest compounds would soon enlarge the avenues of science in contemplating nature. In 1665, Antony Leeuwenhoek found that a glass bead could magnify small objects, such as bacteria and protozoa, as much as 270 times. He designed many models of this seemingly simple screw apparatus. Subsequently, he described these images of nanomolecules in his communications with Dr. Robert Hooke of London, who had previously invented this first original compound microscope.
My interest in ethnobotany also goes back to the fact that together with conserving these plants, we need to know how they were used. And often many local communities, indigenous people, have a wonderful understanding of the importance of these plants, used for medicinal purposes, used for almost any purpose you can think of, and how they have and this traditional knowledge is disappearing, particularly as people move to the city and it's no longer regarded as relevant to everyday lives. So the garden plays a major role in trying to document this knowledge and ensure that it's passed on to future generations and recorded, and to ensure that those who have this knowledge are valued for that knowledge as part of our human patrimony.
Plants, we've grown up with them. We've been around for about 2 million years, depending on when you start the clock ticking, and we've lived in a world of plants. They support us in every way, from food to medicine to clothing, and their beauty refreshes our souls and orients us in a world which without them would be dull and humdrum and uninteresting and not worth living in.
A leaf is one of the most interesting structures that we have in all of life. It can be looked upon basically as a flat plate collector, a way by which plants can use solar energy and convert it into chemical energy, the process of photosynthesis.
Part of what I do is to try to reconstruct the past of flowering plants by looking at their fossils. These are beautifully preserved. And up here at the top, you see the growing tip of the plant. You can look inside on this cut face, and you can see the vascular strand, you can see the leaf traces going out to the leaves, and you can see the fibers.
We used to get all of our ethanol for our cars from plants years and years ago, before petroleum was discovered. We used to get all the chemicals that we needed for all of our manufacturing from plants. As we learn more about plants and how they do things, we're going to be able to do what's generally referred to as synthetic biology.
You should start to think about seeds as information systems.
This plant is particularly interesting to us because we have a lot of interest in biotechnology. When they're small like that, it's very easy to get genes inserted into them, and we actually do that right through the flower. And we can get genes inserted into it, and when they grow up to a greater stage and they're producing these seeds, those seeds will contain the genes that we're interested in. Then we can take those seeds and replant them, and we'll now have those genes expressed in them.
Today we derive about 25% of our current pharmaceuticals from plants, and we're either using the plant-produced drugs directly or we're modifying them for use by pharmaceutical industry. And our specific interest in plant science is to look at how medicinal plants synthesize these drugs. And ultimately, when we can understand the genes that underlie the biosynthesis, we have the ability to use metabolic engineering to alter the plants so that they're either producing more of a drug or they're producing less side products so that a drug is easier to purify than for pharmaceutical uses.
The better you understand the atomic details of how these small machines work within plants and viruses, the better you can modify them, the better you can attack the infections. There's a lot of opportunity in the future for utilizing plants to make all kinds of new nutraceuticals and pharmaceuticals.
My laboratory is dedicated to study molecular mechanism underlying liver fibrosis. In the last several years, we are focusing on a natural antioxidant called curcumin, which is a major component in curry from plant root called turmeric. Curcumin is a very powerful and strong antioxidant.
In India, there is daily consumption of dried turmeric via curry every day. There's 1/4 the incidence of Alzheimer's, arthritis, arterial cirrhosis, and cancer in that population.
About 2/3 of all the people in the world derive their medicines directly from plants. And the great majority of those, incidentally, are not cultivated, they're gathered in nature. And that's true, for example, of both China and India, which together have about 2.4 billion people out of the world total of 7 billion. Even for those of us who live in industrialized countries, about 1/4 of our medicines are based on products from plants.
Aboriginal peoples throughout the world for millennia have used plant sources as means of curing diseases.
We're in the middle of a mass extinction right now. We already have many species going extinct and more being lost every year. Predictions are that climate change will only exacerbate that problem. Right now, overharvesting and habitat loss are greater threats, especially in places like Madagascar, where the vast majority of the forest is already lost.
There has been a lot of interest recently in alternative forms of therapy for diseases such as retinal macular degeneration and glaucoma. Two of the most studied ones include ginkgo biloba, which is thought to be neuroprotective as well as enhance retinal blood flow.
Regarding the importance of cassava in the world, this is the third source of calories in the developing world. It is the sixth source of calories in the world altogether.
Cassava is damaged by cassava mosaic virus carried by whiteflies, and it can seriously cut into the yield of crops. There's an even more serious virus called brown streak virus that makes the roots unedible.
We need to reduce the organization of this plant to something looking like this, what we call embryogenic calli, and then we can put the DNA in there, and from that we can regenerate plants again.
When we investigate what plants have in them, we often find molecules that are of completely original structure that we didn't even know existed. There are hundreds of them being described every year.
There are two groups of algae that we're actually trying to avoid using for biofuel production. One of those is the cyanobacteria, and as I mentioned before, they're not very efficient at producing oil.
I think there's been a long-standing experience, just even with nutritional supplements and herbal medicines, botanicals, that are widely used in the United States and throughout the world. You know, some examples that come to mind are St. John's wort, which is used for mild depression. You have ginkgo biloba, you have kava, you have garlic.
All of these are natural products, botanicals, that really have widespread use.
Formula, first described 1700 years ago. It is used for treatment of a GI disorder. We find this formula actually could enhance a variety of anti-cancer drug actions. What we're trying to do is really creating a new paradigm for future medicine to use.
Cell biological studies using light and electron microscopy are central to the understanding of the behavior of molecules in plant cells. In our studies of tobacco mosaic virus in plant leaf cells.
In a country like ours, the decision will not be made by a single person. It's probably a large fraction of the population has to arrive at the conclusions that we can all accept for these major decisions that we're going to have to face.
All aspects of our environment are changing before our very eyes, yet we somehow still find it very difficult to think more than just a few years ahead.
There's no question that evolution in over millions of years in developing naturally occurring products is a more effective way to develop drugs.
We're at the very beginnings of understanding the human body and the action of drugs and the ways in which it grows and develops, and the more we know about it, the more important the wide array of chemicals in nature will prove to be.
We must recall and respect nature, the first nanotechnologist. The ongoing existence of these many planet interactions merit further embracing of plants and perhaps better evidence-based data, enhanced by tolerant generational lessons, all resulting in more effective cures of the worldly ills.